to Mr. Myers Math Magic. I'm Mr. Myers, and today we're going to be looking at solving consistent versus inconsistent systems of equations. And here we have right here the inconsistent systems of equations. And if you stick around to the very end, I'll be showing you how to escape from these handcuffs using nothing but a paper clip. In terms of inconsistent systems of equations, there are two possible outcomes where there can either be no solution or infinitely many solutions. So when there is no solution, that would mean that the two lines themselves would need to be parallel. So to check this, you would need to identify that the slope for both of the equations are the same and that the y-intercepts are different. And this is just the requirements for two lines to be parallel to each other. The slopes need to be the same and the y-intercepts need to be different. So now when there are infinitely many solutions, you still need to have the slopes being the same. Slopes are the same and the y-intercepts are also the same, because what this is saying is just that it's the same exact line. Y-intercepts are the same. So when you're checking if something has no solution, you can get it into the form of y equals mx plus b, and then you're comparing the m to the second equation and the b to the second equation. If the m and b, or the slope and y-intercept, are the same, there are infinitely many solutions because that's the same exact line. If the slope is the same but the y-intercept is different, that means that those are two parallel lines that will never intersect or cross. And when you're solving a system of equations, what you're looking at is where do they cross. Let's look at consistent systems of equations. Here is our system of equations. And in order to solve a consistent system of equations, that means a system of equations where there is exactly one solution, I can use either substitution or elimination. When I'm doing substitution, what I want to do is isolate one of the variables. For this, it's easiest to isolate the x in the second expression. So I do that by adding y to both sides. Add y, so I know x is equal to 11 plus y. And now what I can do is I can take that 11 plus y and plug it in for x in the original equation. So then I have negative 11 plus 5 plus y minus 7y is equal to 61. And then I need to distribute the negative and then combine like terms. I'll do that now. 7y equals 61. Combine like terms of y. That's negative 11 minus 8y equals 61. Add 11. Add 11. Negative 8y equals 72. After you find one of the values, then you plug that back in here to see what the x value is there. And this is a negative 9 because positive 72 divided by negative 8 equals negative 9. Now plugging that in here, I have x is equal to 11 plus negative 9, so that equals positive 2. So the coordinates for this are 2, comma, negative 9. Now when I'm doing it using elimination, I should find the same thing. So when I'm doing elimination, I either add both of the equations together or subtract them, so that I'm eliminating one of the variables. In this case, if I just add them straight down, that'll eliminate the x, because negative x plus x equals 0. So I'll just add these right here. If you don't have an equation where you have two coefficients that are the same, then this will be more difficult in order to do. You might need to do the step of either multiplication or division in order to find those same coefficients. So now we just add straight down. So that's 72. That's negative 8y. And then you divide both sides by negative 8. Divide both sides by negative 8. Those cancel out. So y is equal to negative 9. And then what you need to do is take that and plug it back in. So I have x minus a negative 9 equals 11. Minus a negative makes it plus a positive, and then I just subtract both sides by 9, and also find that x is equal to positive 2. So the coordinates are 2, negative 9. Either way you solve it, you still get the same exact solution for the system of equations. In this case, it was 2, negative 9. When the coefficients are the same, it is quicker and easier to use elimination. However, when they're not the same, it might be easier to use substitution. Okay. Here I have the paperclip right here, and here are the handcuffs. So what you need to do with the paperclip is to unfold it, and then rock it back and forth a little bit until that breaks. And then here you can use either of these pieces, and in this case I'll use this piece. And what I'm going to do is take this cornered piece and put it inside of the top of the lock. It might be a little difficult to see. And then once it's in there, all I do is twist it, and then that lets go of the mechanism. I'll show you the same thing with the other hand, putting it in right there, and then twisting it, and there it comes off.